I'm Thompson. The work that I'm talking about is the work of a very large team of people. This isn't solely my work, but I'd like to highlight the key contributions of three colleagues, Rob Claxton, Tim Oldham and Phil Radley, who both led on different components of the work I'm going to describe. BT is a multinational company. We started life running the telecommunications network in the UK, and now we operate in 170 different countries. It's one of the Fortune 500 companies. I think it's about 200th in the world in terms of market capitalisation. It's split into 5 operational units and 1 support unit. 5 operational units are the consumer unit, where we sell TV, so we sell football and we sell video on demand, this kind of thing. We sell broadband and fibre products, so high-speed internet. We sell, obviously, voice connectivity and also mobility. We have a business section, which is BT Business, and this sells to SME companies. These are companies less than 1,000 people in the UK, and that business sells data, voice, and mobile services, and also cloud compute services and ICT support services. We have global services, which is what serves the multinationals, and it's 1,000+ employee companies. They sell ICT services, data and voice connectivity, largely WAN connectivity around the world. Our global reach, 172 countries we operate in, and 45 countries we have a data centre in, which is quite unusual if you consider companies like Amazon, for instance, where you see 5 or 6 data centres. We have 45. Wholesale is a business unit that sells to other telcos, so it provides connectivity services for global telecommunications. We have a global network, other telcos use that. We have the UK network interconnect as well. And Openreach operates the UK access network, so this is the network which connects people's homes. And you'll see that I've put some dotted lines there, and those are symbolic. The actual relationship is quite complicated. The dotted lines are symbolic of regulation. So the business is strongly regulated to prevent it from being a monopoly and acting as a monopoly. And therefore we have some very specific rules that we have to abide by when we operate between those different business units and in terms of the exchange of information between those business units. And I tell you these things because this is important in the picture of delivering data services within a real company. People often have the impression that this is relatively simple, kind of like in startup land, where you just have a small company and you set up a database and everybody can use it. Nothing could be further from the truth. We are not permitted to act like that. We have to manage our data assets in a way which is compliant with regulation and, of course, compliant with ethics and all the things that are important in terms of delivering proper service. So that gives you some idea of the complexity of the environment we work in. And we have to provide services to all 5 of these units, and then there's the support unit, the TSO unit, which I'm part of, Technology Services and Operations, and that unit itself requires data services to function appropriately. So there's our top-level problem. We've been at this for a long time. We started off as the General Post Office, part of the UK Civil Service. And in those days we had mainframes, that was it. So we developed a whole estate around mainframes. CSS, the Customer Support System, was the first computerized billing system in Europe, and that was launched in just 1981. Mainframes and the beginning of Unix when we privatised, so we had moved to some client server, and then of course we in the 80s and 90s and noughties, we moved to massive scale classic client server computing. So we operate a federated data architecture with more than 3,000 operational data systems. This is very serious data processing that goes on. Here we are, just some stats. Tens of thousands of instances running on virtualized infrastructure, many tens or possibly hundreds of petabytes of enterprise storage, depending on what you count and what you decide is really there. It's over 3,000 relational database instances which are required to operate the business. These are catalogue managed systems. I'm not talking about somebody's running on a desktop somewhere. We've got many thousands more of those. These are the things that are in the architecture and control, and all supporting thousands of systems to deliver service. So what are we trying to do? One of the things that we're trying to do in order to progress further is to construct something which I would call a network observatory. And the analogy I'd like to sell to you, so this is a pitch, and I'm interested to hear what people think about it, is that just having systems in place is nothing like enough to extract value out of data. And I would give you the example of science, where in the world of science, in order to obtain knowledge, we build an institution. And the institution is made up of people and processes and rules and behaviours and norms. And it's also made of technology. So if you want to understand what's going on in the universe, you don't build a telescope, point it at the sky, have one look, and then announce that you've seen something, right? What you do is you build an institution of people who can direct study, can build instruments, operate them, share them, run them over time. And that's what we're trying to build, and this is the model here. So what we want is to have something which produces instruments that capture data effectively, the data is fit for purpose, and it's done in a cost-effective way. So, you know, if you think about corporate data, I don't know how many people here have actually had an experience of looking at data in corporates. The classic experience is that you see a whole load of plots and then there's a big gap, right? And you say to people, what's the gap all about? They say, oh, well, that's when the system was down, right? Or we missed that run, we ran out of time, or something like that. And everybody seems quite happy with it, right? Now, if you contrast that to the world of science, if your Large Hadron Collider or your genomics experiment produced a great big gap in the data, you'd throw it away. You just say, this is rubbish, this is useless, we can't tell anything from this. And so we need to actually start to move to fit-for-purpose systems in business as well. The reason is obvious, right? We're making very significant decisions based on data now. And if it's wrong, we will lose a lot of money. And it has a lot of authority. You hear quotes like people say, you know, if God comes to the meeting, he can bring opinions, everybody else brings data. I think that was the guy who founded Infosys, right? But the question is what data? Where did it come from? How good is it? And we are very poor, in my opinion, in dealing with this. Okay. Above and beyond that, ways to provide access to it, okay? So we have a lot of rules and regulations about accessing data, managing data, but we have to operate those properly and yet enable utilisation. Otherwise it's useless, okay? Methods of creating analysis, this is a major problem at the minute which is exercised on substantially. The problem is that we used to have a few guys like me, right? I did a PhD in machine learning and I finished in 1997. There weren't many people in those days who did data analysis, right? Real data analysis. It's very common now. In my business, tens of thousands of people are running things on Excel, right? They are doing data analysis. And they are not getting proper value out of that. They're not, they have the appetite to do it, they have the brains to do it, but they're not properly enabled to get the value they could otherwise get. And that's a real issue. It's a real barrier to unlocking value here. And methods of sharing and distributing the analysis that's created. We have a real problem with graphs that circulate around over PowerPoint. And pretty soon, nobody understands where the graph came from or what it meant, right? But it has a totemic value. And people start to talk about it. And they don't know what it is. And this is very difficult. We've got to find ways to manage that. So these are the problems. So where did we come from on the infrastructure front? Really, I think our experience is best summarised as not Linux again, right? So when Linux came out, literally hundreds of groups around the country picked it up and started building things with it. And this was great. They generated loads of good stuff, and then we had to mop it up. And we had to deal with that problem. And we took a very clear decision very early on. We said we're not going to have that. We're going to have a consolidated service strategy in terms of big data and Hadoop. We're going to have one cluster, right? And we're going to impose that, and you're not allowed to build your experimental cluster. So my group, and we are the research group, and we will build our experimental clusters, but no one else in the business is allowed to. Everybody else uses a consolidated service. And that's very important because of cost management on the one hand, but also technology transformation management on the other hand. We want to actually work out what we're going to deploy and how we're going to deploy it, rather than just let it happen by accident. We've got to control this. When we haven't in the past, it's really hurt us, so now we have to. Okay, so I'm skipping forward because we're short of time. Basically, this summarises what we're trying to do. We're trying to build a data lake which is controlled and managed and encourages use with fair scheduling of work. Okay, so we're trying to build a shared asset. And this is why things like Yarn are so important to us, because we want to improve the technology of sharing. We want to be able to utilise this more efficiently and more effectively. What we've built is based on commodity x86, it's Hadoop. We have, as I say, 3,000 other systems out there, they're largely Oracle. We have no plans to stop using relational database technology. There are no plans to junk it. We see this as something which is attracting business into it. So there are lots of use cases where this just works out as cheaper. And we see the relational estate as kind of like a stable of racehorses. This is an elephant, right? You can shift big logs around. We've got this stable of racehorses, which is a beautiful relational database. It's high performance, transactional, super. That's great, keep those. But this is for lugging the logs around, and it's cheaper than having the racehorses do it, basically. We're using very standard things, 10 gig Ethernet, interconnect. We're not using InfiniBand at the moment, maybe we will in the future. Very importantly, we have to control what we put on it around, let me see, well, I'll come to that in a minute. So we've ended up with a production cluster, two production clusters in fact, because of regulation. One is 1.2, both of them are 1.2 petabytes, okay? But we have to maintain the separation, physical separation of systems. We would have, if we weren't instructed by the law to do so, we would have gone for one system because that would have been a more effective approach. The fact is, we have to maintain regulatory separation, so that's what we've done. And it's built out around resilience, essentially, and standardization, standard cheap hardware. Something that we're about to do, we're going to go in January 2015, we're going to build a smaller size off-site DR facility. At the minute, we don't do disaster recovery on Hadoop. We don't put applications that require disaster recovery on Hadoop. Nothing that's running on here couldn't be here we wouldn't miss it if it went away for a week. Right? We're not thinking, we don't allow enterprise vital assets onto it at the moment. We just don't do it. Because we can't do the disaster recovery effectively. But we will be able to so. And there we are, there's a picture of it, it's lovely, it's got black boxes, it's super. The other assets we've got around, we've got research clusters, the old one, which was just a tiny weeny one with a couple of blade chassis and some blades stuck into them. And then we've got a bigger research cluster now, which is traditional kind of pizza boxes. We've got GPU clusters. Obviously, we have traditional big data assets like Exadata as well. We've got one Hadoop cluster which has escaped our architectural control, which floats around in the business, but eventually that will stop. And we're building up to doing a platform as a service offer commercially as well, but that doesn't exist yet. So those are our assets. We built it on top of Cloudera. We went through a procurement exercise to do that. A big thing was the synergies with our enterprise license from Oracle, so we found a good synergy with Cloudera fitted in with our estate. Also, we had some good experiences when we were building a research cluster with Cloudera, and they did well in our procurement exercise, so we chose them. Security is very important. The critical thing here is integration with our current security infrastructure. So again, this is in the real world. You can't just build a security wrap and hope that's right. That won't wash. What you have to do is integrate with the security system that's in place in the business. And for us, that means Active Directory, essentially, and that manages authentication and identity on the customers. There are very strong limits on how well we can secure this compared with the relational state at the minute. So the granularity of control is not adequate for many functions. Right? So there's a lack of granularity in the control of data here. That means that we can't put a lot of data that we would like to put onto this because it's not adequately secured. So we don't. Right? Again, we are seeing considerable evolution in Hadoop, and when we move to later distributions, we expect to be able to introduce other types of data into here because there will be adequate control, and we will feel that we will pass on this if we use it. Right now we won't. So we have a very strong service delivery aspect, and this is one of the things that's been important for actually making this a success, as I'll say in a minute. So we set up a business process to manage the delivery of the service out of the Hadoop cluster. We've been running it in production for 6 months, and we've got 12 live production apps that are up and running on there right now. So, revisiting this is the Network Observatory I was talking about. This is the institution we want to build uptown, and I've got a very faint green bit there down at the bottom. By providing this HDFS-based capability, we've actually got something that we can start building our institution on top of. So how do we actually extract value from it? 3 ways. We're getting cheaper, more cost-effective infrastructure, improved data processing performance. So this is commodity compute, it's cheap. This is that we can actually, instead of chaining ETL jobs across federated databases with a need to data chain the timelines, what we can just do is land data resources in one plate and run things just in one lump, so we get that. And these 2 things hydrate the new business intelligence and insights, okay? When we're going cold into business cases around business intelligence, typically we see a surcharge of maybe £250,000 around acquiring the data assets to support it, okay? And this is something that often is justified by business case, but is simply unaffordable in the context of running corporate budgets. So what we're finding is that these business cases, which are sort of unavoidable, they're the tax of corporate life, if you like, they are actually, by the back door, providing the assets which allow us to do the other business cases. Right? And if we didn't have those, we would be dead in the water, essentially. It just wouldn't work. We wouldn't be able to afford to put the data we need on there. So there we are. That gives me my little green around the data sources that are here. Pink arrow indicating that relational still exists and is providing that. And now stuff has stopped. Oh, okay, come back. So one of the things is understanding the data assets. So that's a key part of my picture of the Network Observatory. In the past, we launched a relational enterprise data warehouse. One of them we launched. We have 4 major ones at the minute. I think within 6 months we have 90,000 tables on it. Right? 90,000 data tables. That's not 90,000 entities, it's 90,000 tables. And nobody knew what was in it. It's very easy to create data assets like that. Already on Hadoop infrastructure, there are many thousands of tables. And one thing that we found is a massive inadequacy in tooling to actually understand where the data is coming from and what's been done to create these tables. So we've actually built quite a lot of tooling of our own. This is one screenshot which allows people to do forensics and check through what has been created, where from, and how it was put together. And this gives us some support in this entity management, this understanding of the data. Insight's very difficult. There are 2 strategies that we could have adopted. One is to get a general purpose insight engine. Everybody would use that, so we'd have a shared skill base, and we'd have one pipeline or data pipeline to actually get the data onto it. These are kind of arbitrary boxes, but you have to do stuff in a pipeline to get data into insight. Alternatively, you can have special engines for doing particular jobs, and you can have separate pipelines. And the point is, this is expensive and difficult to procure in one lump. These are individually justified by use cases, but you have a tax about the skills base afterwards and about the management of the data afterwards. So what we're doing is, in fact, going for a hybrid approach, and we're trying to get a general purpose insight engine, but we know it won't do everything. And we know that, therefore, we're going to have some other components. But then we're trying to unify the pipelines for getting data onto them using the underpinning infrastructure. And there's a problem there. You know, the other problem around this is we've gone from the data science hero, it's me, right, to a team, my team, to teams, right? There are many teams doing this now. And managing that, publishing, sharing, propagating knowledge is just inadequately supported in the state of the art right now. So there we get another green there. Okay, in terms of people and skills, one model would be to have a skills pool of data scientists and manage demand from the disparate businesses into that skills pool. Have a DevOps team up here managing Hadoop. Another model is to have data scientist groups distributed into the business. The advantage of that is that they kind of go native, so they get more domain knowledge and you get transfer between the teams. The problem is that they're not sustainable in the business sense, right? It's very difficult to cope if you've got a team of 5 and 2 people leave, and this frequently happens. And it's unsustainable to have the necessary size of teams distributed into the business. Here the problem is that they become divorced from the business, and we can't fund them. The business won't actually produce the business cases which keep them alive. So we've gone for a hybrid again, and what we're doing is having a small central team which has shared skills and is just about fundable, and then having native teams in the businesses. So these are the institutions of people that we're actually building. This is the strategy for providing the people to use the institution. In terms of applications, I couldn't not talk about any of the applications we're doing. One is around diagnostics, and this is just a case of looking at all the network elements, the components in the network which are producing data. We have millions of devices which are producing data updates on the order of minutes, and we've been able to capture the data from this and start to use it to understand the behaviour of the network in a qualitatively different way, and this is producing significant benefits in terms of network maintenance. Another one is to actually get fine-grained understanding of what the delivery capability is for every line in the country. So in the past we had a whole set of views about different logical groupings of network equipment, but we didn't entail them down to the individual provision we're making. And we've used Hadoop to basically do some very large joins to produce a single integrated table, and then we provide data cubes which give you different commonalities, different commoning of types of kit. So we see interactions between different groups of equipment, and this allows us to pick out things like DSLAM types that are not performing with particular types of router, for instance. And cybersecurity threat detection. So this is actually something that we sell, it's Assure Analytics, and we're using this to understand where threats come from, where attempts to breach our network, where attempts to hack our customers come from, using data stored in big data. And of course, we've all heard recently, this is just the beginning. As the Internet of Things emerges, and we come to have information as a service above and beyond the infrastructure as a service. So these are the applications of the future generated by the Internet of Things. Okay, so we have applications for this thing. So what's the problem? Well, right at the top here, understanding the analysis and doing the data governance, I think there is still a very significant problem in providing that with modern data processing infrastructures. So we've got a big gap there. There's a big topic for research and further work by my group, which will be employed for a while. I'd love to hear counter views about that. The other thing I think here is that actually the ingest of data is a significant problem. I think managing the interaction of relational world to data lake world is significantly difficult. So there we are, that's the two challenges I would point to before we can actually say, okay, we've got something that resembles a network observatory in place, and those are the steps that my group and the team at BT have undertaken in the attempt of creating this institution. I hope it was useful to you, and I'd love any questions that you've got. Thank you very much.